Let's use the power of multi-criteria decision analysis, MCDA, to analyze the data center market. We extracted all the data centers from OpenStreetMap and uploaded them into our Atlas platform. While this doesn't represent all the data centers in the world, it provides valuable insights into the average placement of data centers globally. Now, AI Insights will extract data around these pinpoints and select the most significant factors, those with notable differences between the averages at these pinpoints and global values. This data is then sent to a large language model, which provides us with AI-driven conclusions. This data will help us understand which criteria we can use in further analysis.
So let's briefly review what we found. Typically, data centers are located in areas with high population density and high building density, which means they're usually situated in urban areas. They are also often located in regions with high gross domestic product, GDP, a factor we can definitely use in our analysis. Although we noticed some other unexpected correlations between COVID-19 impacts, solar farm stability, accessibility to hospitals, and OpenStreetMap activities, we won't use it. Another key finding is that data centers are often located near power lines and substations. We should definitely consider proximity to these power sources and GDP values in our analysis. To tailor the analysis for a specific area, let's focus on the USA. We need to generate the first analysis. Let's focus on the natural environment. For example, we want to place data centers in cooler areas to reduce cooling costs. And we should avoid regions prone to disasters like earthquakes and floods. After saving the analysis, by default, platform sets global maximum and minimum values as limits, but we fine-tune them for each area. For instance, we can click on some hexagons to see specific temperature ranges, such as 4 degrees Celsius minimum and 21 degrees Celsius maximum. We can adjust these as limits, setting 5 degrees Celsius as the minimum and 20 degrees Celsius as the maximum. Next, we'll look at disasters. We should avoid areas with frequent disasters, perhaps limiting to regions with no more than one disaster in the previous year. Adjusting these settings, we see that some areas turn yellow due to lower temperatures but no disasters.
We can exclude area with disasters from analysis by setting outliers hide and setting weight as 0 to exclude this criteria impact from final score. Now we've got map with red and green arrows on map. Additionally, the map highlights excluded areas that reveal evidence of a disaster. Nice result. We can move forward.
Let's add more criteria to our analysis, such as GDP per square kilometer, proximity to power lines and power stations. After tuning these parameters, we can zoom in on specific data centers to inspect details, like the average distance to power lines or substations. Let's examine our dataset and check the specific numbers. For example, here we have a data center located quite close to substations and power lines, but it still has a low score. To address this, we can adjust the proximity settings. Let's set 5 kilometers as the ideal distance and up to 20 kilometers as the maximum acceptable range. This adjustment should create a more contrasted map. Next, we'll fine-tune the hexagons that are farther away from power lines. We can do this by assigning a lower weight to distances beyond our preferred range. For example, let's zoom in on a specific area of interest. We can clearly see the power lines on the map, and it's likely that proximity within 1 or 2 kilometers isn't as crucial for our analysis. Therefore, we'll set the weight for this range to 0, which will yield a more insightful map. As you can see, most data points are now in green areas. But we can enhance the visualization further by refining the limits for gross domestic product, GDP. For instance, let's increase the minimum threshold slightly and decrease the maximum by 2 orders of magnitude. This adjustment creates a high contrast map, allowing us to identify areas that lack data centers and have high potential for new locations. These areas with low data center coverage present significant opportunities for future development. As you can see, MCDA has huge potential for comparing locations. With the help of ready-to-use layers, it becomes an easy-to-use tool that can give you insights at your fingertips.